And hello everyone. So, has that come up? Yep. So I'm Paul Sayers, and I'm going to be speaking about the focus on flooding, and particularly how we might start a more integrated approach to assessing natural flood management and its benefits. And the team, it's Sayers and Partners, but with Newcastle, led by Liz Lewis, and UEA with Helen He, and Samkar back at Sayers. I'm just going to see if I can increase the size of this screen. There we go. So for natural flood management, what do we think is the challenge? We know that there are multiple drivers. Flood risk is characterised by multiple drivers. It responds to multiple changes within the catchment. There are multiple responses of how we might respond to that flood risk, and that includes natural flood management, which in itself includes multiple things, woodlands and storage. But we see that as a core response, but it doesn't work alone. So even in our response, we can't just think of natural flood management alone. We have to think of it in the context of other activities. And both of those, if you like, the drivers of change in the catchment and our responses vary in space and time. So we've got quite a complicated picture of how things might change. And if we don't grapple with that interaction, then we're likely to start making the wrong choices, the wrong adaptation choices, make actions in the wrong place that have no benefit, or make actions in the wrong place that have knock-on impacts that we don't want. And it also is likely to lose the benefit of NFM within that more complex picture. So we have to grapple with those interactions. And that's really where OpenClim comes in. That allows us to start capturing all those complexities, at least in some extent, and how they are spatially varying and how they temporally vary, to start providing a new insight into natural flood management. So I'll just say a little bit now about how we've approached it. This is the general workflow that echoes the one that Robert showed earlier in general terms, and we're trying to bring these models together to say something new about natural flood management. And I'll just illustrate some of those external pressures that the catchment is facing. We've already heard that the SSPs translate to quite a strong variation in development as well as climate change. And these are some of the maps we saw earlier about the development changes. But there are also a whole bunch of other external, what I've called external pressures on the catchment that, again, OpenClim has been exploring that we try and bring forward. So we've got the pattern of urban development that we just heard about, how that changes in the future. But from Rachel, we've just heard that there's variation in where agricultural productivity is likely to increase or decrease with time. And we've heard from Rachel around the changes in conservation and restoration priorities. So where we think we want to conserve and where we think we want to restore as a priority is also varying. Now, all of those activities are important, but they're outside of flood management normally. So for us to think about flood management, we have to bring those together into some form of coherent catchment change, as we've called it. Some coherent catchment scenario that recognises all those external influences and recognises where we might choose to adapt and where the opportunities for natural flood management might be. So we've developed what we've called this coherent catchment scenario, and this is one of the outputs of that. We've called it the NFM max. So if we try and maximise those locations where we might do natural flood management, these are those places, taking into account some of those other pressures on the catchment. On the left, where we might look to implement storage, and on the right, where we might look to implement woodland. We are working on some other NFM versions that aren't just the max, but that is work in progress. So it's okay to have that idea of where we might do the storage and where we might undertake restoration for woodland, but we have to try and convert that into a hydrological response. And within OpenClim, there are two models being run, two hydrological models being run. SHETRAN, which is a physically based hydrological model that Liz Lewis and her team are running, and one is the HPV, a more conceptual model that Helen He is running. Now, both of those models represent the normal things that we might expect, catchment processes, evapotranspiration, routing, infiltration, etc. But we've had to think about how we modify those to represent natural flood management. And I thought I'd put up here of how it's done. It's always through proxies, really, in some form. And I thought I'd expose how we did it in the CCRA 3 if we included natural flood management in that. But that was really just based on case studies. So what have case studies shown about natural flood management? And we reflected that in the CCRA 3. But here, HPV and SheTran allow us means of doing it much more directly and spatially. So HPV does it by slowing the flow through modifying some of the conceptual parameters, and SheTran does it much more directly. And Steve Birkinshaw at Newcastle has been working on how you do it. Woodlands are relatively straightforward, but storage is more complicated, and storage is key for natural flood management, whether you can implement it, but it's much more difficult to represent. But we've got this idea of a leaky storage. So we incorporate a leaky storage where we see a storage opportunity that has a volume of storage and has a residence time within that storage. So how does that end up actually with changing the flows that we see, the hydrological response? And we can look at that with and without those NFN adaptations. And on the left, we see the reduction in the 10-year return period flows under a 2-degree future, and on the right, under a 4-degree future. So I think one of the interesting things is actually you see NFM having some additional potential from a flow reduction in a more extreme future. So in that 4-degree future, the map on the right, visually at least, it highlights that perhaps it's having more of a benefit in that setting than it is in a 2-degree future, both of which are important. Another advantage of OpenClim with these multi-models is you can start thinking about model uncertainty and whether you get different results with two different process models. So this graph is showing a comparison between the percentage change in the hydrological flow for the 10-year return period with different degrees of warning. The orange bar is from HPV and the blue bar from SheTran. HPV is fairly flat as warming increases and typically slightly more than SheTran. But in the SheTran model, we can see that the potential reduction in flow is increasing as climate change increases. So that blue bar is increasing to the right. Let's get that on for purpose of time. Then we were looking to convert that, because hydrological flow response doesn't tell us necessarily that much about flood risk. There are other processes that we need to account for if we're going to translate that natural flood management adaptation and flow change into some form of risk change. And there's a few things that are often important. Flood defences and how they perform, and sometimes even a really quite small change in flow can have quite a material impact in the way flood defences behave. So that's an important thing to represent. Exposure, where people are, is varying. So even though you might be changing flood flows a lot in this location, perhaps no one's there. So it depends on that interaction between where the flood flows are changing and where the people are is important. And also, often people say, well, NFM isn't going to do much for the very extreme events, which may be true, but risk doesn't respond to that sometimes. And from an expected annual damage case, it responds to how those much more frequent events are being managed. So we put that into the mix, into the model. The Future Flood Explorer captures those interactions, and we can start thinking about the change in risk. And what I'm going to show next is the project still going. So these are interim results. So with that caveat in mind, still, I think, useful to show. So what can we say about the role of natural flood management in flood risk at the GB scale? So I'm showing two sets of bar charts here. The brown are the 2-degree future and the reds are the 4-degree future. And the large bars are the whole portfolio of adaptation. So this is thinking about defences, warning, the whole range of adaptations that we might normally consider, albeit a slightly reduced version of them. We're not, but a whole portfolio. And then on the right, the smaller bars are the NFM contribution. NFM Max is the one that we've run. The NFM Max contribution to that broader portfolio. You okay? Oh, sorry. Have I been playing to a blank screen? Yeah, so the red bars are the NFM contribution to that adaptation portfolio. And it's quite significant. This is NFM Max, but nonetheless, it's quite significant. And interestingly, it gets bigger with a more extreme climate future. In England, we see a picture, and because England tends to dominate the GB risk, we see a similar type of pattern. In Scotland, we get quite a different picture. Now, notice the y-axis is a much smaller range. This is, unfortunately, a sixth of the range before, so they are a sixth smaller. I did originally keep them on the same axis, but you actually can't see the distinction there. So for Scotland, it's much smaller. Not only the adaptation overall portfolio benefits are smaller, as you'd expect, but the contribution that NFM makes to that adaptation contribution is smaller, which again is what you'd expect, because the opportunity for modifying the Scottish landscape through NFM is smaller. So those national bar charts don't tell us that it's not the same at all locations. So it's, and we have to look at the map to understand where are the real areas where reduction might be largest. So here we're looking at the percentage, the contribution of NFM in pounds to the adaptation effort. The darker the blue, the greater the NFM contribution to the pound reduction in risk through adaptation. And we can see that there are clear areas of the country that NFM is much more important for as part of the adaptation mix. And here we can also see it as a percentage of that adaptation effort. So in some places, adaptation reduces risk by a much bigger amount, so you'd expect NFM to be potentially bigger, but this map is showing us where NFM has the biggest percentage contribution to the adaptation effort. So it really highlights some of those places where we're expecting NFM to really be a core aspect of the overall portfolio. Okay, so what does all that lead to from emerging insights? Well, some policy insights, and I'm sure most people will agree with many of these in our community, but woodlands, soil, storage, they are legitimate assets. They are legitimate flood risk assets that help us as part of that portfolio response. NFM has a potential to reduce the adaptation deficit, order of 10 to 20% across the country, more locally. And I haven't touched on it here, but the value of NFM goes obviously beyond flood risk into natural capital, which OpenClim will continue to think about going forward. Method insights. Well, I think the key one is to understand a proper flood risk management adaptation response. You have to think of how it's connected with the whole system response, not only NFM, but NFM within that context. And OpenClim is really starting helping us to understand that relationship. And next steps, well, there's 1,000 next steps, how long have you got? But I think we've really started building this quite powerful platform that we can start to use to explore advances in science, new models, and improving the underlying data sets. I think there really are strong possibilities here for hopefully we can take that forward into the next CCRA and beyond. Okay, thank you. Back to Richard.